Hello everyone, my name is Abhishek and welcome back to my channel. So after the recent AWS outage, everyone has been asking how DevOps engineers can design the infrastructure in a way that the infrastructure can handle outages. In today's video, let's try to understand the exact same thing in simple words. I'm sure this is also going to be a very popular question in the interviews. So just try to watch this video till the end. First of all, let's try to understand what exactly is an outage. So when you consider cloud providers, they have their data centers across the globe. So what usually cloud providers do, if you take example of Amazon, so Amazon decided that they will have their data centers in regions like Virginia of United States, Ohio, then few data centers in India, Asia Pacific. So within each region, instead of a single data center, they usually have multiple data centers. Now, these data centers in the world of cloud computing are called availability zones, and these are called regions. Now, zonal outage is basically where one of the zones in the availability zone can go down, whereas regional outage, which is very, very rare, is the case where an entire region can go down. So when I say region can go down, that can mean that the entire region customers are impacted, which is what happened on 19th and 20th of October with AWS. So their US East 1 region was entirely impacted. Now, why do I say zonal outages are common? Because that is also the reason why cloud providers have availability zones, multiple availability zones within a region, because there can be as simple as power outage in the zone, or there can be any manual issue within the zone, which can take down the availability zone. But this is not a major impact to the cloud providers because they always recommend customers to have their workloads across multiple availability zones in a region so that even if one of the availability zone goes down, they still have the Virginia region serving traffic on two other availability zones, right? So overall, what I'm trying to explain you initially is that there can be two types of outages. One is zonal outage and other is regional outage. And zonal outage is common when compared to regional outage. Now let's try to understand how cloud engineers or DevOps engineers should design the infrastructure. Now there are multiple things, but very important thing is high availability. What is high availability? So imagine you are working as a cloud engineer and you have decided to deploy your workload onto a virtual machine on US East 1 region and US East 1A availability zone. So you have your application deployed here. And for some reason, let's say US East 1A, the availability zone goes down. Then obviously your customers are impacted, your organization is impacted. High availability is a thing to eliminate single point of failure. That means if US East 1A goes down, you should still be having your customers happy. So basically you should serve the traffic to the customers using other availability zone, or maybe using multiple other availability zones. High availability is basically keeping system operational even when components fail. Now, in this case, in the example that I've taken, the component can be virtual machine in US East 1A. Even if this component fails, you should have your other components in other availability zones so that the customers are not impacted. Or basically, you can consider high availability as reducing the blast radius during the outages. Now, how do you design the high availability. Okay, you understood that high availability can help you during the outages by having copies in different availability zones. But how do you exactly design that? Now, if you take the virtual machine example again, so instead of having your application deployed onto US East 1A or typically to virtual machine within US East 1A, what you can do is you can spin up a virtual machine in US East 1A and other virtual machine in US East 1B. You can front face it with a load balancer. If we consider Amazon, so you can front face it with an application load balancer, and this application load balancer constantly checks the health of both of these virtual machines. And depending upon the algorithm that you have selected, let's say you decided to go with round robin. Okay. So it checks the health of this virtual machine, this virtual machine. So as I told you, this virtual machine is in US East 1A and this virtual machine is in a different availability zone, US East 1B. Now, after constantly checking the health check, if both of these virtual machines are active, let's take this case. ALB forwards few requests here and few requests here. For some reason, if this virtual machine or availability zone 1A goes down, then what the load balancer does? It checks the health check every 5 seconds constantly. So in the next 5 seconds, it realizes that, okay, US East 1A goes down. So it forwards all the 100% traffic to virtual machine in another availability zone, that is 1B. So this way, your customers are not impacted. Of course, this virtual machine will be overloaded. All the 100% requests goes to this virtual machine using through some alarms, monitors. Once you understand this virtual machine is down, during the time of outage, you can increase the resources on this virtual machine so that, you know, even on 100% traffic, this virtual machine can handle the load. So this is a basic high availability design, and this is what we call multi-AZ architecture or multi-AZ design. Now this can be with databases as well. So if you have databases, let's say this virtual machine is connected to a DB. So you can have your DB instance in this availability zone and DB instance in this availability zone. But the challenge here is how do you perform replication? Because all the time this DB and this DB should have the same data. So basically you can enable replication, right, which we call as cross availability zone replication, so that if user writes data to this DB, right, so it replicates the data onto this. And similarly, if user writes data to this DB, you can enable replication to the other one. Or basically you can have one of your DB as active and other one as passive. This is called as active passive architecture. In active passive architecture, load balancer constantly forwards the request only to this particular environment and keeps this environment as backup. That is US East 1B database as backup. Again, if this availability zone goes down after 5 seconds of health check verification, now because this DB has all the information of this one, so even if the user workloads go to this particular availability zone, this virtual machine and this DB can handle the requests. So these are two types of architectures, even with multi-availability zone, which we call as active active, active passive. For this video, I'll not get into details of active active and active passive because I'll try to demonstrate sometime both of these architectures and how exactly they work. Now, what if both of these availability zone goes down? So as we understood at the beginning of this video, there is also something called regional outage, which is rare, but it can happen. Recently on 19th and 20th of October, Amazon faced this. on US East 1, which is a very, very popular region for them. Almost 35 to 40% of AWS traffic is served on US East 1. Now, what do you do in these cases? Because all the availability zones within the region are down. So even if you design a multi-AZ architecture, your customers will be impacted. In such cases, you will have to go with multi-region architecture. I mean, to handle such outages, you will have to go with multi-region architecture. Something like this. You know, this is what we have set up in US East 1, right? An application load balancer, forwarding the request to two virtual machines or two applications in VMs, and that storing the details onto a database, and maybe using S3 bucket as the storage option of the database, right? Now, in multi-region setup, instead of one region, we try to implement same things in the other region as well, right? Exact same architecture, just create a copy of this architecture onto another region. So it can be US East 1, and this can be maybe US West 2. If all of your customers are in United States, you can pick up one region as US East 1 and other region as US West 2. And both of these regions have to be a copy. Let's say you're using GitOps approach for deployments. You can configure your GitOps controller to deploy parallelly onto US East 1 and US West 2 so that both of them can be carbon copies. But Abhishek, in case of an availability zone, application load balancer is balancing the load between two different availability zones or VMs in two different availability zones. Now, what happens in case of multi-region? So in terms of multi-region, you would front face both of these regions with a global load balancer. In simple words, if you're using Amazon, you front face it with Route 53. So now Route 53, users requests are received by Route 53, and Route 53, using its algorithms, it decides to which region the traffic has to be forwarded. Should it forward the traffic to application load balancer in US East 1 or application load balancer in US West 2? And from there, application load balancer again performs health check on the virtual machines and forwards the request to the applications. Abhishek, what load balancing techniques do global load balancer use? Again, it's the same thing. Active, 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 passive are the most important ones. But what Route 53 does, it looks at few things. Like you can say Route 53, look at failover. So it constantly looks at both of these regions, right? And it sees if there is a region that is running into outage or if there is a region that is down, during that cases, it will fail over to the other region. That is 100% of the traffic goes to the region that is active. Or you can say Route 53, go with active, active architecture. So it will constantly forward 50% traffic to region A and 50% traffic to region B, right? So you can design your infrastructure in active, active or active, passive, even when you're going with multi-region architecture. But are there no challenges, right? So when it comes to multi-region, is it easy to set up? At the high level, it looks easy to design because, when you look at this diagram, it feels like just copy one of the region and replicate the entire infrastructure onto the other region. But there are definitely challenges. For example, when you are dealing with multi-AZ architecture, that is multi-availability zone architecture, you can stick to one VPC because usually in the cloud providers, VPC is spawned across the region. So if you create a VPC, you can use it in US East 1A and US East 1B and even 1C. But when you're going with multi-region architecture, your VPC is only tied to a region. So for some reason, if you want to have your workloads in different regions to talk to each other, maybe to replicate the data or maybe to interact and get some resources, you should enable something like VPC peering. So you create VPC in region A, you create VPC in region B, and you enable communication using VPC peering. Not only that, replication of data is not that easy when it comes to databases. That is cross-region replication involves a lot of things when you are dealing with databases. Even you have to enable S3 cross-region replication, which is not out of the box. Lot of services on AWS, they make it easy for replication within a region, within availability zones. But for cross-region replication, you might have to write some custom scripts or you might have to provision your Ansible playbooks to enable cross-region replication, right? And other thing is costing. When it comes to multi-region setup, it costs you a lot because you have already enabled multiple availability zones. Now to add to it, you are replicating your data. That means if you have two availability zones in US East 1, where you have your infrastructure, now we are making it 4 with two more availability zones in US West 2. So cost becomes duplicate when compared to multi availability zone setup when you're going with multi-region setup. As I told you, I'll talk in detail about active-active and active-passive architecture. Especially, I will make a video with respect to Route 53, how you can use failover architecture with active-passive, and how you can design active-active architecture and enable global load balancer like Route 53. Now, what is the key takeaway of it? Within your organization, because of these outages, should you just go back and implement multi-region architecture? I would say no, because not every company needs multi-region architecture. You have to perform something called cost versus performance. So go to your organization, try to interact with your management and understand what exactly is their priority. You know, are they okay with 95% SLA? Are they okay with 99% SLA? Or are they looking for 99.99% SLA? If your company is looking for 99.99 SLA, and if they sign the contracts with your customers, then probably you are looking for a multi-region architecture. Because 99.99 is a very strict SLA, and you cannot afford even things like global outages or regional outages. Whereas if your customers are okay with 95 to 98% SLA, then multi-AZ architecture should be fine for you, because entire region going down is very, very rare. It happened recently, but that doesn't mean it happens quite constantly. Another thing is, you should always try to build, as cloud engineer, as DevOps engineer, go with vendor neutral architecture. This is very, very important. So recent regional outage of AWS was an alarm. Imagine if this happens 4 times in a year. Your customer might understand once, but if it happens quite constantly, you know, you might want to move your entire infrastructure from AWS, because that has become a bottleneck for you. If you want to move your infrastructure out of AWS, and if you depend a lot on AWS managed services, then it becomes difficult for you. So whenever you are designing your infrastructure, try to build a vendor neutral infrastructure. Very simple. If you have your infrastructure on EKS, probably I would consider it vendor neutral because it's easy to move to AKS. Although you are tied to AWS with EKS, but underlying it's Kubernetes and moving to AKS should not be a big deal. So always you choose your services in this way. Or maybe you can spin up some virtual machines and install Kubernetes on top of it. In that case, it's even easy for you to move to a different cloud provider. Kubernetes is just an example. I'm trying to say design your infrastructure in this way. Also, whenever you're designing infrastructure, understand everything about the cost. Lot of cloud engineers, they are good with designing this infrastructure. They are good with enable cross region replication, deploying applications to multiple availability zone, using load balancer, using global accelerator, but they fail to understand the cost. For example, if you're using services like Kafka, or maybe if you're working with some databases, and if you're going with manual replication, let's say you have one of your Kafka broker in US East 1A, and you have other Kafka broker in US East 1B, you have deployed these brokers manually. When you try to replicate the data, it involves in cross zone replication costs as well, right? So always try to understand the cost that is involved, not only about uh, costing of each resource, but also try to understand the egress costing, try to understand any ingress costing that is involved, try to understand any replication costing that is involved, so that you can help your organization while designing the infrastructure. If you have any questions related to this topic, or if you want me to make a video on anything specific with respect to outages and designing your infrastructure, do let me know in the comment section. See you all in the next one. Take care. Bye bye, everyone.